Lights, camera, fractions.
Oh shit, you guys, that was weak.
It was.
Okay, you guys. So up to this point, we've been talking about inequalities. We learned how to solve an inequality, and we realized the only time we solve it just like an equal sign, like an equation, except that if we multiply both sides by a negative number, or if we divide both sides by a negative number, the inequality sign flips, right? So that was easy. And then we learned, after solving them, we learned that we got x is greater than 3, and we used, there's only one x, there's one variable, right? So we only needed one line, right? So we didn't have to do a big coordinate plane, you know, with 2 dimensions in it. We only needed a one-dimensional line so that we could go x is greater than 3. So here's 3, here's 0, open circle, x is greater, right? Right? Now we go into the real thing. Because in life, it's very seldom that you have everything is just one-dimensional, right? There's always more than one, often more than one dimension. So we're going to be talking about 2-dimensional graphs and inequalities. So they will be things that have an x and a y. Or at least that's how we will be thinking of it. And I'm actually going to start by graphing something with only one variable. I'm going to graph a one-dimensional thing on a 2-dimensional plane here and see how that looks different. So for example, I taught you before where you had like x is greater than negative 10, right? You know, that was just a one-dimensional thing. You would go draw a straight line like this. This would be your 0, this is your negative 10. You said it's greater than, so it doesn't equal it, it's just greater. So we have an open circle, and we go that way, right? And that's how you graph it, right? Pretty easy, right? Now, however, you can graph x is greater than negative 10 on a 2-dimensional plane. And you will have to know this really, really well. So if it confuses you at all, just learn it, practice it. You've got to know it really well. All right, so I'm going to draw a 2-dimensional plane. In other words, a coordinate grid, or a, what else are they called? Cartesian plane. 1, 2, 3, 4, 5, 6. 1, 2, 4, 5, 6. 2, 3, 4, 5, 6. 6. Okay, that's good enough. So this is my y-axis. This is my x-axis. And I'm going to graph, maybe not x is negative 10. I'll do x because I don't have 10 things. I could do it. Ah, what the heck, we'll just do it. We'll graph x is greater than negative 10, right? X is greater than negative 10. We'll graph that over here. So let's think about that for a second.
Do we go to 10?
Well, it's saying that we got x's and y's, right? But we've got x's and y's for this graph, but it's only telling us about x's. It says x is greater than negative 10. So when I do this personally, the way I think of this, when I'm doing a one-dimensional problem on a 2-dimensional graph, I think of replacing this. Instead of x is greater than negative 10, I say x, this is what I actually think in my brain. I think x is always greater than negative 10. Okay? That's what I think. And I'll tell you why. First of all, let's just find where is negative 10 on the x-axis. I start here, right? And I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's negative 10. So x is greater than negative, so I'm going to just put a dot there for now. Okay? Now, you'd think I would just draw an arrow like I did here, right? Like I did here, right? But but I have a question. It doesn't say anything about y. But if you're in a 2-dimensional plane, you might not be on the x-axis. You might be down here somewhere, right? would you agree with me that x is still always greater than negative 10?
Yes.
So down here it is too. So even down here that is. What about up here somewhere?
Yeah.
Oh, it's definitely always greater than negative 10. It makes no diddly squat of difference what y is, right? As long as you always have that condition that x is always greater than negative 10. So that means I actually have to create a line, a vertical line that connects these dots basically. So I go to negative 10 and I do a vertical dot, a vertical line. Now the question is, what kind of a line? There are two kinds of lines. You can either have dotted or dashed lines, right? Or you can have solid lines. And you know how over here, when we had no equals, when it did not equal something, we had an open circle? Which one of those would you think would be sort of like an open line? The dashed line. So this is sort of like an open circle, right? So we're going to have to make this a dashed line because it doesn't have an equal sign. If it was, if it's a solid line, it would have greater than or equal to, right? Then it would be solid. But for this, if it says just greater than, it's going to be a dashed line. And it all says greater than. So I'm going to do a vertical dashed line at x is negative 10. I mean at negative 10. And that dashed line is where I begin. It does not include that line. Does that make sense? Because it doesn't say it includes. It says it's greater than that. But that's my boundary line. This is actually called a boundary line. And it's that boundary line where it all begins, and it all moves this way, right? So instead of doing one arrow, I actually have to shade all of this over here. And I'm going to show you how to do it. I don't recommend doing arrows parallel to the x-axis. I recommend doing your shading like this.
Okay, so you can shade all of that?
So yeah, and this tells you that all of this is the solution. Anything over here, and obviously it would keep going forever and ever. All of these have like arrows on the end, but I don't bother with that.
Everything that is within the boundary is solution.
Correct. So give me a solution to this problem. X is greater than negative 10. Ben. Any solution. Meaning I need a coordinate point. Give me a point.
Oh, okay. -9 and 8.
Yeah, totally. -9, 8, right? This is a point. This is a solution. 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 All of this is a solution. All over there is a solution. Albuquerque is a solution.
You just have
Right?
to start on the boundary.
It just has to begin here. Doesn't include the boundary because it's dashed, right? Make sense? Okay. Clear? Fist of 5? Awesome. Good. So what if I said this? Graph.
4.5.
So now let's say I did this. Let's graph. Let's use a different, well, do I have a different color that works? I do. Hang on. That's kind of cool. I just opened a new one. But don't anybody touch my new ones. Oh. Okay. Now let's say I did this. I said, graph this. Y. Oh, lovely.
Gary, why don't you try the green?
Yeah,
No reaction.
Gary, the green
Oh,
one. The green one.
You guys are welcome to touch that red one.
Good try.
Horrible. Okay. Y, let's say I say y is less than -3. Y is less than -3. So how would I do that? Well, that means y is always less. Makes no difference than -3. It makes no difference what x is. Y is always less than -3. So I go down on the y-axis to -3, I put a dot. Oh, but if I'm over here, I'm not always going to be on the y-axis. Over here I might be over here somewhere. Well, y is always going to be less than -3, and y is always going to be less than -3 here. So I'm going to actually have to put a dotted line here, right? And it says y is less than that. Which way would I shade? Down. Now, I would not shade like this. Why? Because they're parallel to this other shading. I never want to shade parallel. I want to actually shade like this, opposite, right? So I can actually, and you'll see why later, because I'm actually doing two things at once. But anyway,
Why does oh wait, so
so
if it's y, then
it's y. If it's
the-
y,
it's just
y is always less than -3. Here's -3, -3, -3.
okay.
Draw my line, and I go below it.
So it's just been rotated.
For x is more than -10, couldn't you shade the other side to like the first quarter?
Oh yeah, I could have. This goes on forever.
Okay.
The shading goes on forever. Yeah, thank you. Good question. The shading goes on forever. I just didn't do it. I could have kept going.
Could have kept on
Right.
do the floor.
Right? Okay. So that's that. Okay. So now I'm going to erase this mess, and now we're going to look at equations that have two variables. How are we doing time-wise? Okay. Well, but this won't take. I don't think this will take too long because you guys know. You know the basics.
Gary, Michael, take a picture.
Quickly, Michael, take a picture. Quickly.
You failed in his mission.
I'm sorry. I realized I had already gotten 90% done. So it'll be on the video, right?
Then I'll take a picture.
Oh, Gary's not an
Gary,
investor.
Please put the video up tonight,
Yes.
not on Sunday.
I
Oh,
know,
okay.
because that's a pain.
Okay.
Or
I will.
on Monday morning.
Okay.
Really?
All right, here we go.
Then it's just useless.
So guys, everybody in your notes, quickly, draw a graph. Draw another graph.
Oh,
Okay?
how long?
Doesn't matter.
Any line?
Just six digits.
I really don't care. I'm just putting lines everywhere. I am. I think all of them are off. 1, 2, 3, 4, 5, 6, 7.
Okay.
1, 2, 3, 4, 5,
All right, here's
6,
my
7,
y,
8.
here's my
1, 2,
x.
3, 4, 5,
Now.
6.
Okay, guys, really, it's time to really focus, okay? Guys, really listen. So we got, I'm going to say, let's graph this. Y is less than, I'll say less than or equal to this time. Let's say 2x minus 5. What form is that in? Isn't that like a slope-intercept form?
Yeah.
Y, as long, except that it has the less than sign, right? Less than or equal to. But it's still in that same slope-intercept
So
form.
do we
I still know that this is my y-intercept. London, you get that?
Yeah.
That's still my y-intercept. That's still my slope, even though that's the less than sign. It's still the same basic thing, right? So it's really easy to graph. So I go down 5, 1, 2, 3, 4, 5, and I put a dot, right? Just like you guys know how to do these. And then it's rise 2, run 1, right? Because my slope is 2 over 1. So I rise 2, run 1, put a dot. Rise 2, run 1, put a dot. And then I can draw my, well, actually,
Rise 1. No,
rise 2, run 1. Rise 2, run 1.
Where do we start? Oh, right.
At -5, right? So now I'm going to draw my line. Now the question is it solid or dashed?
Solid.
It's solid, right? Because it also equals that line, right? So it's got to be solid. All right, so my line is something like this. Okay, beautiful. Now this is the tricky part. That part's pretty easy, right? This is the tricky part, and it's not hard at all, but people make it
Do
hard.
we have to shade like the down part of the line?
Well, you can't go by that, because it doesn't always work. Sometimes it works and sometimes that doesn't. So she's saying, oh, well, it's always going to be the down part because it says less than. It doesn't always work that way. Technically, if it is in slope-intercept form, it does actually technically look that way. But they're not all going to be in slope-intercept form. That's
I meant
why.
the ones that are in slope intercept.
Of course you meant that. But they're not all going to be in that, and I'll show you that. So I'm going to show you the method that always works, okay? Because you have to decide which way to shade. And would you agree with me? Did you notice that last one we did? When we had x's, here was -10, right? X was greater than -10. And we shaded everything over here, right? Everything. Everything on this side is an answer, right? So but nothing was an answer on this side, you remember, right?
Yeah.
So remember that. So any point on this side could be a solution. Let's say, or any point on this side could be a solution, right? We don't know which one it is. So what we could do, and this is the part, really stay focused. You, with me, London, you listening?
Yeah.
Because it's really critical you get this. You choose a simple point, a really, really simple point, and see if it's true. We're going to actually take a point and substitute it into this equation.
You could make it 0.
0, 0, like that origin right there, that's
That'll
0
work.
comma 0. That means x would be 0 and y would be 0.
Oh, no.
That's a great idea, Ben.
Oh,
It's
okay.
brilliant. It's brilliant.
Is that sarcasm or is it true?
Now
I don't know.
If it is,
now
I'm
let's
crediting
let's just make sure we got the logic down.
you.
If we're going to take the x and y and we're going to substitute in here, if we get a true answer, if we get something that's true, like 4 is bigger than negative 5, right, or something like that, then that's true. That is a solution to this inequality.
But it's not
That
a solution.
means this, everything on this side of this line is a solution, right?
That makes
Now,
it-
but what if we get a false answer? If we get a false,
Wouldn't it actually, wouldn't it,
if
no.
it's true, if
that's not true.
okay, let's try it. Let's just try it.
I've already did it in my
0
head.
is
0
less than 0 minus 5, so 0 is less than or equal to negative 5. Is that true or false?
That's false.
That's false,
How
okay?
about how about 1?
Therefore,
zero?
If it's
nothing,
zero-
this is
Wait,
not
how
a,
about 1 and 0?
but wait, no. Well, you can do that too, but 0, 0 is really easy. That's the easiest one. And since 0, 0 is not a solution, nothing on this side of the line is a solution. Does that make sense?
Yeah.
Absolutely nothing. You have just eliminated, you've actually just figured out the answer. It's going to always be the other side. If this is false, all the points that are true are on the other side of the line. Makes sense. It's logical, right? It's got to be all this side or all that side. And if it's not that, it can't be all this side, right? So it's got to be this side. So I'm going to shade it like this. Does that make sense?
Oh, it did it.
And that's how you decide.
Gary.
Don't reset.
Gary,
Oh yeah, sorry.
wouldn't
Take
another,
a
easy,
picture. Sorry.
wouldn't another easy way to know what the answer is to just look at the equation? If y is less than or equal to 2 over 1x minus 5, since you're subtracting 5 and y is less than or equal to that, wouldn't you be able to know that the right is correct?
But what if I had said plus 50?
Then it would have been left.
You're right, it would. Yeah, you're right. So, but basically, well, that's what I was saying, with the slope-intercept form, it actually does work to say, oh, this y is this line, right? And it says y is less than this line, so you can just sort of go what's less, right? Which is like gravity, like where if you dropped a pebble, wherever the pebble would fall would be your answer, right? But when you have different kinds, let's see, when you have this, can I erase? Did you get it?
Alright, rewrite it.
Dude, that was like 5 minutes ago. What did I have up here? Y is less than or equal to
2x minus 5.
minus 5.
And 0.
And then we said 0 is less than 0 minus 5. 0 is less than or equal to negative 5. That is false. Okay, now go.
Is the picture taken?
Great.
Hurry!
Okay. All right. So guys, you gotta really focus. Don't anybody talk right now, because I'm over time and they are gonna ding the bell any second. So watch this. What if I had this? 2x plus 3y is greater than 12. Because this is not in slope-intercept form, you can't say, oh, it's going to be above the line. You don't know until you actually solve it.
Don't you have to put it in something?
You can, but remember, how do we graph these? An easier way besides putting them in slope-intercept is
You cover one and then
Right. to find the y-intercept, I basically make x 0. So 3y is, just think of it as an equals for a second. 3y
you have to
is
make
equal to
one
12
set.
divided by 3y is equal to 4. So I'm going to go up to 4 on y, right? 1, 2, 3, 4 and put a dot. And then I'm going to make y 0 to find my x-intercept.
6.
So x is equal to 6. So that means x is 6. That's over here. 6, right? So I know that's my line right there like that, right? And then what? And then, so that, is it going to be a solid or dashed?
Dash.
Right, good. Okay, so that's my, now I got to figure out how to shade. Now, using our method, your method, you think, oh, it's got to be up. Maybe it is, but it won't always be, right? We'll see. So we're going to use 0, 0 again. 0 plus 0 is greater than 12. Is that true? Is 0 greater than 12?
No.
No. Therefore, this is not a solution. In this case, it is up.
Yay.
But sometimes it won't be. Like if I had made that minus 3y, it wouldn't have been up.
It would have been down.
It would have been down. Right? I think.
Can't you just tell
0.
me the sign? Like,
Wait,
not
hang on a
necessarily-
second. I could be wrong. Hang on. Let me think about this. Because it would still be 0. Oh, but it would be a different line. It would be a different line.
So it would be down.
I don't know. I'd have to do it.
Oh. I thought
But the point is, you don't use that to decide. You use this method. You substitute an easy point, like 0, 0, and see if it's true or false. And then you immediately know, right? Instantly. Okay, that's it.
No, wait. Oh.
I'm going to just